It's my pleasure to introduce Björn Sommer. He's currently at the University of Konstanz in Germany, but has very recently been at Monash University in Australia, where he's working at a lab there with, very lucky to have a Cave 2 system. And Björn's presentation is titled 3D-Stereoscopic Immersive Analytics Projects at Monash University and University of Konstanz. And this presentation will be wholly and solely in 3D, so make sure you've got some glasses. Björn's going for the, trying to get that title of best 3D presentations during the conference.
I'm giving my best, yeah. Yeah, thanks a lot, Andrew, for the nice introduction. Yeah, very exciting presentations here. So I will not focus so much on the technology behind it. I will have also 1-2 slides talking about that, but I more want to focus on the different applications. So on some of the applications I was directly participating, but there was also a number of projects which maybe I just were participating, for example, in experiments in Monash. So here you see my co-authors. So I will say some words to them later on. First, a short introduction. So the title was involved in immersive analytics. So we had already from Todd Margolis last year, we had a talk here about immersive analytics. So it was maybe or it still is a hyped metaphor for what we want to do. So of course, most of you will know the term visual analytics. And I think the big difference to visual analytics is here that in visual analytics, you normally try to break problems down as easy as possible, and this is also normally why I use just 2D visualization, which does not mean there are no visual analytics approaches which are using 3D, but immersive analytics is now focusing on problems where you really want to make use of 3D visualization. So the idea is here to investigate novel interaction technologies, and we just saw now some very nice approaches how you can do this by using HMDs, by using caves. The objectives in here, for example, that you want to immerse the user in the data which he is using, then you want to implement collaboration support, and you want to implement, for example, multisensory feedback. So indeed, the slides are at the moment in 3D, but you can also watch it in 2D. I don't know if you notice it. So let's go on. A few words about the visualization facilities behind this. First of all, I want to say a few words about the Immersive Analytics Initiative. So a number of researchers are involved in that from various fields. So coming from bioinformatics background, from human-computer interaction, from biology, and so on. And what we are using are fish tanks, like the Z-Space. Some of you might have seen the presentation yesterday, the HMDs, power walls, and also, of course, caves. So we are making use of the Monash Immersive Visualization Platform, the SensiLab and the Immersive Lab in Konstanz, which is quite new. It's tried in 5 different application areas. So some of them only Monash is involved, some are also already done in Konstanz. So we have first of all life sciences, which I'm working in. So disaster management, we will see an example about this, business intelligence and logistics, design and fabrication, and education. So we have the MIVP, Monash Immersive Visualization Platform. And this is located in Clayton, Melbourne, and it uses different technologies. So the Cave 2, you will see a slide of this later on, and the HMDs. And here we also have the support of different programmers. So this means that many people are coming from abroad with different problems. So this might be, for example, coming from industry, from art, from science, and they are experts then in implementing this and showing this then in the different fields. The SensiLab. It was quite interesting because I also saw a slide before in one of the presentation about democratizing immersive experience. Here's also the idea: we don't want to use very expensive technologies. We just want to use affordable technologies, and this is done in this lab, and it's also done in a playground area. And this is also very interdisciplinary. So you have artists which are involved in this, coming from scientists, for example, school students, and there are many different senses which are involved, like, for example, that you have haptic feedback, which is involved, And you have different other approaches like using electronics in this context, 3D printing, robotics, and of course also sound. So let's come to the projects. So first of all, this is about the visualization of the Great Barrier Reef. So the Great Barrier Reef is a UNESCO World Heritage, and as most of you know, so it's close to Australia, but we have a big problem there, that we have severe threat problems with that, and it's shrinking more and more. And the objective is here to use immersive analytics to assist here in reef education, so to show people what are the problems here in this context. And this is how it looks like. So now you need the glasses. So this is a mixed reality system. So you see here on the top, this is for my colleague Yunim, who created this. He's actually just arrived now in Konstanz. We will work together. But he's normally localized in Monash University. So this is a mixed reality system. So you see this is more an array of 2D displays. But what you can do here, you can visualize the crown of thorns, sea star. So they are one big threat to the to the coral reef, because they like to eat a lot of this coral leaf partitions. And on the other hand, you see here that you can visualize here. So here you have a heat map, which is visualizing this. Then you have here the coral growth, which is shown here by using here this bipartite graph. And on the top, this is an interesting idea. He is using Google Cardboard, and he can actually then, when he uses this cardboard in conjunction with the 2D mapping, he can show then the crown of thorns sea star in this context. So another project is called Swarm City. And here we try to visualize the climate change scenario. So this is not published material. It's from 2000. So the idea is to have a look into the future. The problem is already this Elwood. It's a part of Melbourne, and it has already severe problems with flooding. And they are trying now to simulate what is happening actually in the future. And for this particular purpose, they are using immersive 3D visualization and try to simulate this. So this means they try to simulate the environment, and they use a parametrically modeled 3D environment, what you can see here. So yeah, these buildings which you see in the background are parametrically modeled, and the idea is to find out if, depending on the flood, how far it's perturbing into this area, how severe are the problems then for the people living there. So another project I presented this last year, here I was directly involved, and maybe if you participated in the demo session, you saw the Z-space, which I used for the implementation. So here was the idea, how could we optimize cave presentations? Now come a few slides about the cave 2. And in context of this cave 2, how could I use the Z-space to optimize the navigation here? And for this purpose, I have here a view. So now I will explain Dan, the cave 2, what is it? He will be very surprised. So, so we have a number of nodes which are connected to an array of monitors. So in case of Monash, this were around 4 monitors for each of the nodes. Then we have a server in the center, and he's controlling this. And what I was doing then, I extended this by connecting it to a Z-space, and the Z-space could be used then for navigation. You will see it on the next slide. By the way, there was a question about the price tag, so it's around 2 million, I think. But the good message is it's only Australian dollars, so it's not actually so much. So. So here you see a video which I took in the cave. So you see that I can use the Z-space to navigate in this environment. So the idea is you have this 3D model of a cell. You can click onto different positions inside this environment, and then you can navigate to this. And the idea is now, as Dan was already mentioning, this is very good for group presentations, the cave 2. So if you have a group inside your cave, that you can point on different positions. So you can have predefined tours in your environment, and you can click on different tour points, but you can also freely choose, for example, a specific position in this environment, and then navigate to this specific position. This is, This is an alternative to the head-tracked approach, which is normally used, which is optimizing the 3D perspective only for one particular person, but it's not optimizing it, of course, for the whole group. So another very interesting project, I was not directly involved in this, was from my colleague Maxime Corday at Alia, and he was making some comparisons. So nowadays there are a number of papers out there which are comparing caves versus HMDs, and what they were using here was, as an application case, was a network. And for example, they had a counting task, so counting different nodes of this network. And what you see in this context is, in the background, you always have two persons which are collaborating. And in terms of the cave 2, of course, you could see each other. And by using the HMDs, we had a DK2 Oculus Rift, and you could just see the sharing head and the finger positions. And the outcome of this is, so the paper was published end of last year, was that the HMDs are faster, so all tasks could be solved faster by using the HMDs. And it was quite interesting that the cave 2 introduces movement asymmetry, because you always had these two different persons looking into two different directions and trying to collaborate on the graph and to merge the results which they found out there. And actually they are working on a follow-up study by looking at flight trajectories data. So the next thing, this is more from the technical point of view, is N-Cube. This is a new framework which was developed by Danny Wohl at Alia. What they were trying to make some large-scale volumetric rendering framework. So we were using in the past OmegaLib normally. I think I also talked last year to Dan. They are also using this still. But they tried to optimize it for the volumetric rendering. And to give you an idea what is the background here, so you have different units. You have on one hand you have the manager unit, which is trying to synchronize the different tasks. Then you have an interaction unit, which is used, for example, for the tracking capabilities. And then you have here the process rendering units. Here you see, for example, the different rows. So as I said before, we had 20 different computers which were communicating with the rows. And here you had then this approach which is used for the synchronization of the visualization. Then the other thing what we are actually doing, we actually started this project already in Monash, was that we are using, in the context of membrane modeling and visualization, which also quite popular work in this context always, to look at the biological behavior of membranes and to simulate it. And for this purpose, we were using here this new power wall, which we just built, so it was just more or less finished before I submitted the paper. So, and what you see here, it's just an array of 3x2 different displays, and this will be very interesting to talk to Jörg later on, because we just set it up. These are also OLED displays with 4K resolution. So, and what you can see here, we have on one hand, this row is used for 3D modeling. So this is a stereoscopic display of a membrane in a more simplified way. And these membranes are then simulated with GROMACS. This is a molecular dynamics simulation frameworks. And after that, you can visualize it here with VMD, which is also a popular tool. And both you can use just by using side-by-side stereo visualization. With these monitors, you can visualize it now. And this is then just used for the 2D visualization of the user interface. So this here is my favorite project from Melbourne. So this is Angkor Wat. The background is here. It was constructed in the 12th century. And so archaeological surveys confirm that you have a road grid pattern. We will also see this later on one of the other slides. So this was implemented with Unity, and the objective was here to explore this virtual environment on one hand. So you have a very large environment which can be explored, which you see here in the slides. And you have a simulation which is focusing on 24 hours. So, and you see here now this different characters which were modeled. And the approach was as first, we of course had to reconstruct the complete temple. Then you had to integrate different models, sounds and textures. And then finally you had to simulate this. So this is based on tracking thousands of different characters. And you have, of course, many different target groups. So archaeologists, for example, are interested in the simulations, but you can also use it, for example, in the context of schools. Just as you read, was nominated. So Angkor Wat, the topic Angkor Wat was nominated as a key study, and so it will be quite interesting to use this, for example, with HMDs in the future, or to get students involved in the Cave 2 in this environment. And here you see also this previously mentioned grid-based pattern again, which is around the temple complex of Angkor Wat located. Leading is Tom Chandler, this project. It's already a project which is running something like 10 years. And it's very impressive. So I come to the outlook. So for all these projects, or for 3D stereoscopy was a very, very important technology which was used in the context of all these projects. We have also other projects, especially we are looking now to web-based approaches, which we are thinking about also to integrate this in a stereoscopic way. And another approach is contextual, which is partly making use of Sage 2 also, which is also working in this context and should be working in the future on 3D stereoscopic vision. So yeah, so if these are the links to the different projects. And here I have, in the end, I have a nice video which is from David Barnes, who is the leader of the MIVP facility. And this is another very interesting project from Laos. I'll just keep it running in the background. So if you are interested in the different projects, just ask me now or later. I can just connect you to the different persons which are directly involved in that. So, and with this, I would like to thank for your attention.